using synthetic division. This is section 6.2. The first thing I want you to do is make a little box off to the side. In that box off to the side, I'm going to put the number 2. Okay, where did 2 come from? Well, it came from right here. This is in the form of x minus a. A is going to go in this box. A is not negative 2, a is just 2. Okay, so I want you to think of it as it's going to be the opposite of what you think it should be. Okay. The next thing I want you to do is to write the coefficients and constants right here. So I'm going to kind of spread it out a little bit. I'm going to write 1, just writing my coefficients and constants for my polynomial. -4, 6, and -4. I didn't have any missing terms in this polynomial, so I didn't have to add any zeros, but if I was missing a term, I hope you would know to add in a 0. In your notebook, skip a line. Okay, skip one line and draw a horizontal line. So this is the setup. This is, I think, is the hardest part. Where did this 2 come from? It's A. It's what we were divided by. It's in our binomial denominator. Where do these numbers come from? Coefficients and our constants. Alright, so this process is not too painful at all. The first thing I want you to do is bring down the 1. Okay? What we're going to write down here below this line that we drew in, that's going to be our answer. The 1 comes straight down. We don't do anything to the 1. The next thing we're going to do is multiply. 1 times 2 is 2. So we're going to put 2 right below the next digit. Then add. What's -4 plus 2? -2. Okay, so I'm putting -2 there. And I'm going to repeat this process. I'm going to go multiply, add all the way through. So -2 times 2 is -4. So I'm going to put -4 below the next digit. And then I'm going to add. What's 6 plus -4? 6 minus 4? 2. Multiply then add. Multiply then add. I'm ready to multiply. 2 times 2 is 4. Okay. After multiply, we add. -4 plus 4 is 0. This 0 right here is our remainder. We have a remainder of 0. What I want you guys to do is to kind of block it off from the rest of the problem there. It's our remainder, so we put just that line there to keep it separate. If 0 is our remainder, what would you guess 2 would be? Working backwards to my answer. Remainder, constant. What's -2 going to be? -2 x, and then 1 is x squared. Okay. Our answer when we divide a polynomial, the exponent here should be 1 less than our original problem. If this is x cubed, our answer is going to be x squared. Okay, it should happen like that every time. So this is my answer right here. I'm going to clean this up a little bit. Hey guys, if you have earbuds in, I want them out of your ears so that we're paying attention. Okay. We have x squared minus 2x plus 2. That is our answer. Wasn't that much faster than polynomial long division? And you'll get even faster at it. It'll be something you'll go through real quick. But that is our answer. Okay. Let's try another one. We have 2x cubed plus 3x squared minus 4x plus 15. And we are dividing by x plus 3. What's going to go in the box off to the side? This is in the form of x minus a. What are we subtracting? X minus a -3. So a is really -3. I want you to think of it as the opposite of what you think it should be. It looks like it should be a positive 3, right? We're going to put -3 in the box. Okay. Let's list our coefficients and constants. We do not have any missing terms, so we don't have to worry about that for this first problem, or the second problem. 2, 3, negative 4, 15. So we'll see my coefficients and constants. Please skip one line in your notebook and draw in that horizontal line. What do we do with that first value, that 2? Bring it down. We don't do anything to the 2. Come straight down. And then we repeat that multiplication add process. So 2 times negative 3 is negative 6. Now add 3 plus negative 6 is negative 3. Then multiply. Negative 3 times negative 3 is 9. Negative 4 plus 9 is 5. 5 times negative 3 is negative 15. What is this number right here, the 0? Remainder. Go ahead and block it off from the rest of the problem so we know that it's a separate deal. It's our remainder. If 0 is a remainder, what's 5? 5 is our constant, negative 3x and 2 x squared. This is 1 less than the original problem, isn't it? Okay, the exponent is what I'm referring to. Is 1 less than the original polynomial. So I'm going to write my answer as 2x squared minus 3x plus 5. How about this one? 4a to the 4th power plus 2a squared minus 4a plus 12. And we're dividing by a plus 1. What's going to go in the box off the side? Negative 1. Did you guys catch here that we're missing a term? Which one are we missing? A cubed. So where that a cubed should be, what are we going to put there when we list our coefficients and constant? Put a 0. So I've got 4, 0, 2, negative 4, and 12. What if we were missing our constant, our 12? What would we put there? Put a 0. Okay, so any of those positions, whether it's a variable or the constant, if it's missing, put a 0. Okay, so let's use synthetic division to divide. What happens to that 4? Well, it comes straight down. Don't do anything to that first term. Now I want you to repeat the process of multiply, add, multiply, add. So 4 times negative 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 1 is 4. 2 plus 4 is 6. 6 times negative 1 is negative 6. Negative 4 plus negative 6 is negative 10. Negative 10 times negative 1 is positive 10. And 12 plus 10 is 22. What is 22? Remainder. Go ahead and block it off from the rest of the problem. You know that's our remainder. If 22 is a remainder, what's negative 10? Constant 6, x, negative 4, and positive 4 is x cubed 1 power less than the original polynomial. It was 8. Well, I made a mistake here. I shouldn't have used x. What should I have used? I should have used a. Let me go back and change that. That should have been an a. To a cubed, a squared, and 6, negative 6a. We have 4a cubed minus 4a squared. That was a positive 6. Positive 6a. Goodness. Minus 10. And 22 is our remainder. We're going to write our remainder just like we did with long division. We're going to say plus 22 over what value? A plus 1. The binomial we were dividing by was a plus 1. Our divisor. The next time I want you guys to try. See if you can do this on your own. I'll come around and check your work. So when I write my coefficients, I have 1, 8, and 7. What am I going to put in the box off to the side? Negative 1. bring down my 1. 1 times negative 1 is negative 1. I add, I get 7. Multiply negative 7, I get 0. What is 0 again? Remainder. 7 is the constant. 1, x plus 7 over here. Alright. Huh. I guess it is Andy also, isn't it? Oh, I would do that. Today we're using synthetic division. It's much faster, isn't it, than long division? It's a little less painful. But there are some instances where you'll have to use long division. Let me just explain this real quick. If there was a coefficient in front of this x, like let's say it was a 2 there, I wouldn't be able to use synthetic division until I do a little bit of work. In order to make this work, I would have to divide every term in the denominator and every term in the numerator by 2. And then I would have a bunch of fractions and decimals, so I wouldn't be able to do this as easily. This is what it would look like. I have to divide everything by 2. Because doesn't this have to be in the form of x minus a? Okay, not 2x minus a. This is where long division would be much nicer than synthetic division. But today we're practicing synthetic division. And the problems I want you to try are on a PDF that are already posted on Google Classroom. You do not have to do the last